Topic 1, the introduction and basic flowsheeting to ChemCAD. We're going to tour the ChemCAD interface, just take a look at what all is on it, that sort of thing, and go around it. Once we've covered all of the items from the menus from the interface, at least briefly, just kind of explain it all, we will build a simple flow sheet, just tell you how you get started, what you need to do to even make some calculations. We'll specify everything. We'll run the simulation, essentially make the calculations, and after that we'll save the simulation and be done. So basically it takes you from turning on ChemCAD to being able to run some simulation and get some sort of calculations. When you turn on ChemCAD for the very first time, this is what you'll be looking at. You'll see different panes around the screen. You can change any of these, move them around the workspace, different orientations as you prefer. The same thing with the menus and the shortcut buttons and the toolbars. It's all customizable. Kind of work with items here in the main screen first, and we'll get to the toolbars and the menus second. We have the ChemCAD Explorer pane, and if you look at the bottom of this pane, you'll see that it has multiple different tabs. Recently used files. This is a very fresh install of ChemCAD, so we don't have any. By the end of the day, you will see some of these recently used files, but it's for quick reference if you want to see the latest, most recent ones you've used. Once we start doing work, that tab will switch to the simulation tab, and that's got just different tree structure with different data for the simulation. This can be in the large icons, or if you right-click in white space, you have an option to switch it to small icons. It's your preference. I like to use the small icons. I can see a little more. I can make this be a little skinnier so I don't encroach on my workspace over here. So I'm going to leave it as the small icons, but you are free to do it how you want. The third and final tab on the ChemCAD Explorer pane is Visual Basic. If you start doing some custom programming in Visual Basic, which is not a topic that we're going to cover today in the ChemCAD Essentials course, this is where you could access some of that. Kind of following in the circle, counterclockwise manner, we have the errors and warnings, or I should say what we call the messages pane, where we have the errors and warnings. We have run trace and notes. Errors and warnings are anything that ChemCAD needs to convey back to the user, that it's done a data check. You've got things that are errors, meaning things didn't converge, possibly, or that you don't have enough things specified, or you have too many things specified. Those types of things ChemCAD needs to convey back to the user so that the user has some sort of knowledge and idea of what is happening in the simulation. We print that here. Run trace would be if you want to see the calculations of the simulation either as it's going or after it is completed. You can go back and you can look through the different calculations and each iteration that it went to in order to converge. The Notes tab is used if you want to put any notes to yourself about this simulation. It will be stored in the simulation. It will always be in the simulation. It won't change unless you change more notes. So it's a kind of a quick, easy way if you want to, you make changes as you go along in a simulation. You want to note those changes. Hey, I tried this. This is the result. So I switched to this. This Notes tab is a good spot to do it. I've seen people also do it on a separate file, Excel, or a separate maybe Microsoft Word document or something to that effect. that can be done too, but the notes gives you the ability to do it, and it stays with the simulation. Continuing around, we have the palette menu, or the palette pane. This is, just as it says, the palette with all of the tools that we draw on the workspace with. We have unit operations, and we will get through each of these. We've got a stream, which connects all the unit operations. We have just some graphics, rectangles, and things that you want to, if you want to pretty up and or add them to differentiate different sections, things like that. Text tool. We have feed and product, which aren't necessarily unit ops in the sense that they do things, but they are the start and end points of everything. And we have different bars that you can click on that have different categories in the palette. ChemCAD 5 symbols are the symbols from when it was ChemCAD 5 and we used a color variation of the unit operations. And we have just kind of subcategories or specialized categories. If you want just the drawing symbols, just heat exchangers, just piping and flow. You can even make your own search if you want to do just say heat or anything that might be a heat exchanger, including all items off of the subpalette. Show up. As you can see, we have a little icon here, kind of a person that symbolizes that it is a user-created bar or category. You can save this, you can rename it, you can remove it. So if you want it always to be up, and certain you want to create your own little groupings, that can be done. With any of these panes, we have little controls here. The first one is a push, kind of looks like a push pin. It's this push down in the downward direction pins the pane to be always fixed as it is. If we click it and we see it's kind of in a horizontal position, then it is a fly in and fly out. So it goes away when you don't need it, and you just roll your cursor over it when you do, and then you can use it. This is how I typically set it up when I use ChemCAD, because I like to have more workspace here, and the palette I only use at certain times. Basically at the very beginning, I'm going to use it a lot, and then later on occasion as I need to rearrange or change the drawing of the flow sheet. But for the most part, I don't need to use the palette all the time, so I leave it minimized off to the side. You can get rid of them altogether by clicking the X, and then they go away. If you do View, Explore for the Explorer pane, the palette, messages, and the status bar. The status bar is what was down at the bottom. We'll get to that in a second. So you can have them show up or be gone. You can even remove them from where they are and undock them, or put them back and dock them again. So it's up to you how you want to use it, but that is kind of what you're looking at. The status bar is down here. We convey information about ChemCAD down along this bottom as well. Right now we are in steady state mode. If we were in dynamics mode, that would change, and you would have the time that dynamics is running in. In a second, when we get into doing a simulation, you will have your thermodynamic information down here. What is the K value that, or the K option that you're using, as well as the enthalpy option that you're using. When you do sensitivity studies and you have multiple steps that you're running through, that information will also be conveyed down here. So there's a lot of useful information down on this status bar as well. We have toolbars here that have shortcut buttons. This section or this grouping is all for zooming. This one, as you can see, select components, thermodynamic settings, editing feed streams, and running. The little dots signify that you can move these around You can delete them and change them. As you can see that this little icon is the same as this one. They basically do the same thing. There's just two different ways to get there. If you look here and you see it again, this is the third way to get there. So we've got, and if you pay attention to the icon that's being used, and then here is you got the symbol for the thermodynamic settings, you can kind of tell that that is the same ones because they all have the same symbol to them. We just give you multiple ways to get there. Everybody works and thinks in a different manner. Some people prefer using shortcuts. Some people always use menus. Some people really like to explore. So we give everybody, or try to make it as conducive to being and working with how you like to work as opposed to us making you think in a particular way. It's set up very similar to any other Windows program with the menus across the top. File, the open, close. You can even export them to AutoCAD and things, prints, exits. The edit is for editing, undo, redo, things like that. That's pretty standard Windows formatting there. The view, we saw that a little bit on the different panes. We also have some grid things for in the workspace and flow sheet settings, which don't make a whole lot of sense right now because we have nothing on our flow sheet, but when we get IDs for unit ops and for streams, we can show them, we can hide them, we can show color for when things air out. All of those are controlled here. If it's something that you see, it's under the view menu and we can control. Under the format menu, we have different ones where we can format our lines and arrowheads and just colors and things like that. But the biggest one that people will use here is the engineering units. And we'll take some time and we'll go through that screen. If we select Format Engineering Units, here we can control whatever units you want to do the calculation, or you want to see your information in. If you want to, after the calculations are done, you want to see them in a certain units, that sort of thing. Right now, we are in what we call ChemCAD's internal units, or the standard units that ChemCAD does all the calculations in. Pound moles, that you see at least. Pound moles, degrees F, liquid volume rates in feet cubed per hour, things like that. You can create whatever a set of units that you want to do, and it can be done basically in multiple ways. There is one way that you can do it is you can just do it on the flow sheet itself, which we'll see in a little bit because we haven't gotten to that step yet. We can do it at the simulation level only, for globally for all the simulation instead of just at individual spots in the simulation, or we can do it for all simulations here and in the future. We do that by creating a profile. Pound moles don't make a whole lot of sense to me. Pounds do, so I like to change it to pounds. Feet cubed per hour don't make nearly as much sense to me as gallons per minute do. So I'll change that to gallons per minute. Heat capacity, again, the pound moles, I'm just going to get rid of and put it BTU pounds. Same thing with specific heat, BTU pounds. For the most part, I will leave, well, let's change diameter. Diameter, we're going to change to inches. That we will see in something a little later on. But we can always come back and change this at any time. So right now, we're in English. If we would push the English button, this would all go back. But I'm going to change it, and I'll just give it my own name. And I'm going to save this profile. Now, this simulation and every simulation, or I should say, this simulation will have all of these units. But load default, oops, the wrong button there. You can see it changed back to English units. That is going to be what every future simulation would be. It would still go back to the default one, which is English. And you can see we have some other ones pre-programmed, formal SI, metric SI, but let's go back to the profile we just created. And now we can save this as the default. Now, instead of just this simulation being in these units, all simulations that I do in the future will be in these units. This can be very useful in a couple of different ways. One, every plant that I know of has their own way of, their own set of units that they want to work in, so you can just set that up and work in that. The second way is if you're not working necessarily at a plant, but you have multiple customers that are running different things and you're doing work for other people, every single one of them will probably have their own units as well. So you can make a profile for each and every case, each and every possible unit in a plant, each and every customer of your own that have different units. Set it up. All you have to do is come up. You can make the default be whatever you want it to always make sense to you, but then all you have to do is come in here and load the profile, and it will change the units across the entire simulation. You can do it now at the beginning of the simulation, or you can do it at any point in time in the future of the simulation, and it will convert all of the numbers into the units that you see on the screen right here. We're going to leave it with the profile that I created and leave it as the default. We'll click OK. We'll continue across the menu here. We'll look at some more items. The thermophysical. This is where we select our components, our thermodynamics, everything like that. Basically, there are three aspects to doing a simulation that are needed. We need a flow sheet, kind of the unit ops, the set unit ops, the order in which they go, that sort of thing. We need to have components and their physical properties, and then we need to have the way in which we're going to do the calculations, the thermodynamic settings. What is the K value? Are we going to use activity coefficient? Are we going to use equation of state? That sort of thing. And that all, the thermophysical stuff can all be accessed via this menu here. From looking at stuff in the component database, selecting your components, to get into the thermodynamics. As we get into the simulations, we will start to look at some of those. Specifications, exactly what it says, what it means. If we need to specify anything, like the feed streams or how much in the feed and that sort of thing, we can access that from here. Run, that is basically the calculate button. You know, if we need to actually run and make it do the calculations, this is where we can access some of these things. Convergence screen is controlling some of the calculations, you know, how tight and that sort of thing, different tolerances, different things that we can control. Run, we can run all or just run some. The recycles, sensitivity studies, optimizations, different things that we can do calculations with. Once we have things calculated, we can do reports on them. We'll get into this a little bit later once we start looking at it. We can do plots. We'll have data. We'll look at some of these down the road a little bit as well. Sizing, same thing. We're going to look at these, but we can do sizing on different unit operations and such like that. Tools, we can do some economics, some costing. We can do units converting. We can do just using just a simple calculator. We have other options, preferences. We can control where reports go to. Internal report viewer is what we're going to see, but you can send everything to Excel if you want as well. You can create your own shortcuts, keyboard shortcuts, those types of things are all controlled under options. Windows, that's a standard Windows command or a menu option there. And then we got our help as well. Generally, we set up the menus across the top for how you would set it up, getting started, just what you want to look at, kind of the things that you'd have to set up, specify, and then run, and then we get then a report from when we're done. So we kind of work from left to right as kind of how the simulation needs to function. The plot sizing and the tools on the end are different tools that you can use either during and or after a simulation that you've done. So they're just extra things that can help you along. We do have a couple of shortcut keys that people find helpful. The standard F1 cuts to our help. Has all the different information about the different things. You'll see a help button on a lot of our dialog screens, which I'll point out as we are moving along as well. That'll kind of jump you to that area. There is the F7 button, which just brings up that calculator, and you may have seen that under the tools, F7, and then again under the tools, units calculator, F6. If we bring up the F6, that's all of the units conversion that ChemCAD can do. So we can come in here and we can type in a temperature and we can do units conversion for temperature. You can get there all that way. Or for the units conversion, there's a different way to go about doing it when you're in dialog screens, and I'll go over that as well when we're doing a simulation. I think that covers everything on the screen, basically just on what you look at when you are dealing with ChemCAD. So at this point, we will start to draw a simulation, now that we understand kind of what we're looking at. Let's get into the meat of the matter. We use ChemCAD as a calculator, so let's start doing some calculations. While I'm drawing, sometimes I tend to pop that back out just to leave it there. As I said kind of earlier, everything starts at feed arrows. You click once, put the feed arrow, and you can click again. And it ends at product arrows. In this case, we're going to have two feeds. And we'll have two products. Three products make that. I'm trying to think of this in my head as the process that we're going to go about. We're going to take just an ethanol water mixture, and we're going to just separate it through a heat exchanger, cool it down through a heat exchanger, and then just do a flash separation of it once it's cooled down, if we need to, depending on how cool we've made it. For our heat exchanger, we have just what we call a simple heat exchanger. Process material flows in and process material flows back out. We just simply state the temperature change, possibly enthalpy change, that sort of thing, a heat duty we want to add, that sort of thing. But if you notice that we've got kind of this black corner, kind of the representation is it's peeling back. There's kind of something underneath this. If we click in that corner, we get what we call the subpalette. So there's a lot more unit op icons that we can use. The difference between this unit op icon and this one is nothing other than the drawing. The difference between this one and this one is a little more complex because we have two streams that can enter and two streams that can leave. We know we have two streams that can enter and two streams that can leave by the red and blue dots. You may or may not be able to see it real clear now, but when we start drawing the stream, that will become more evident what I'm talking about. The blue dots are inlets. The red dots are outlets to any unit operation. For heat exchanger, if you only have one in and one out, it's the simple one. If you have two in and two out, then it's what we call just the standard heat exchanger. And there's a little bit different screen for it. So we're going to, oops, did that wrong. We're going to just click on the heat exchanger we want. We'll just use heat exchanger 5. And then click it once, that is. We can move it over to the palette, or to the workspace. We move it around to the spot we want, and we simply click again. We also, like I said, are going to use a flash. We do have more options for flash. I'm just going to pick the standard flash, the first icon. So as we put it on here for in ChemCAD 6, we notice that we don't see those blue and red dots that we saw on the palette when it showed the picture of the icon. We will see those in just a second. As we pick the stream drawing tool, our cursor changed from just the white plus sign to a little black pointer. Or not, I'm sorry, not white plus sign, but the white pointer to the little black pointer. That means we're in stream drawing, and then when we get away from it, we get the black plus sign. When we get close enough to it, the red dot shows up, and we get the little black pointer. If we click once, we have made a connection at that outlet, and we get a little kind of crosshairs-esque drawing to kind of give you an orientation of where the stream is drawing. And as we get closer to the unit op that we're going to, we see that all of the inlets and outlets show up again. Again, the blues are inlets, the reds are outlets. All streams are drawn from a red outlet to a blue inlet. We can choose either one of these inlets that we want. We'll just pick here, and then we're going to pick out and click again. And then for all the, now if you notice that it picked this dot because that was the one it felt I was closest to, we've got 6 different inlets that we can put to this flash unit operation. Which of them we choose is entirely up to us. There is no difference between them. When they all go in, they all mix first in the flash, then the flash routine happens. So you can pick them. It's just we put 6 there simply for a convenience to the user, so that way they can put multiple inlets into a particular unit operation. We're out here, and then click again, and we'll click to the product. Now I didn't do the stream yet here. If we want to change and put this more to the center, we can. We can click on the stream so it's highlighted. We know it's highlighted because it has those little black dots. Right-click on the stream itself, and we get a menu. We can do different things with this menu, but in this case, we're going to do Reroute Stream. And we can come over here, and we can get a little closer to a different one. And now we've used that one instead. That's just kind of showing you how to do it. Again, it makes no difference of which one calculations-wise it goes to. It's just how you want to see it. If you notice the numbers that are going on here, these represent the stream and unit op IDs that I mentioned earlier when we were looking at the view flow sheet settings, and we can hide or show the IDs. When ChemCAD creates a stream or a unit operation, it automatically gives it, I should say, a stream and a unit op ID. Under standard, normal circumstances, it starts counting at 1 and goes sequentially up from there. If you have, say, 10 unit operations and you remove one of them in the middle, say number 5, the next one that you do place will take that spot and be number 5. It'll always try to fill in gaps, but it tries to number sequentially up. Every unit op and stream have to have a unique ID to them. ChemCAD forces this and makes sure that it has so, because that is internally how ChemCAD understands which stream is which and which unit op is which when it does its calculations. All streams are in squares. All unit ops are in circles. So that's how you can kind of tell the difference between them. If you right-click them, you can change the stream ID. You just can't give it the same ID as something else. You can give it a name, and you can give it an alphanumeric name. That's fine. The names don't have to be unique. The names actually can match some other stream if you want it to. I don't understand why you would, but if you're maybe just do it by mistake or something to that effect, that is possible. But the IDs will never match. You will know the ID when you double click it. The ID will be up right here. For a simple heat exchanger, because we only have one stream connected in and one stream connected out, which is similar to the very first icon I showed on the palette, you get the simple heat exchanger, as you can tell by the dialog screen here, the menu or the dialog screen for that. You can only specify one thing here, temperature going out, possibly subcooling, maybe a heat duty, but only one thing, and it will change. Continue. It will change the stream coming in to there. When we click that, it went through and checked and did an error check for us. This is what I mentioned earlier. We get some feedback from ChemCAD as to what's going on. It said, hey, we have an error. There's no specification done, so that unit op is not ready to do any calculations yet because it cannot function with this error. I just wanted to show you that screen, and now if we do here, let's finish our drawing. If we double click now, we get a different screen. This basically is showing that we've got two streams coming in, two streams going out, so I've got to use the little more complex, the standard heat exchanger screen for this. Again, we get some feedback here. So just kind of showing some of the unit operations and how we go about drawing things. Before we go any further, we need to specify our components as well as what we're going to do calculation, the equations we're going to use to the calculations. We can go here, thermophysical, select components. We can click here to select components, or we can here and select components. Let me move this over so we have a little more viewing. And as you can see, we got this, but we also have flow sheet unit ops, and we got streams. We can access things from here. More information here on this, on the Explorer pane. As we keep building, this information keeps filling in. So we go to our select components. Everything on the left-hand side of this screen is what is available to us to use in a simulation. Natively, ChemCAD has 2,277 components built into it. The majority of this is coming from Dipper, but not all of it. We do have some others that we have done, but that is the main source of our data. You can have user-added components. If you do that, they will be at the bottom of this screen. We will see how to do user-added components and working with a component database a little later at the end of the day, but know that they will just show up at the bottom of this list. We can do searches, and the search can be on 4 different items, from the ID, which is here, the name, the CAS number, or the formula. We're just going to search on anything that is checkboxed will be searched on. Anything that's not, we'll ignore. When we do a search, we do a string search. We want ethanol and water, so let's type ethanol. And well, the first item it finds is methanol. The reason is the word ethanol, this E-T-H-O-A-N-O-L string of letters is right here in this word. So it found it. That's not the right one. We can just click next and find the next instance of that one that we find. And that's the one we want, ethanol. If you notice, this 134 is also 134 here. The CAS number is the exact same. There is no difference between these two components other than this name. The reason it's listed twice is to give people options when they're trying to search on a name. Some people may refer to this as ethyl alcohol. Some people may refer to this as ethanol. So if you type ethanol, ethyl alcohol, we want that to be able to show up. If we type ethanol, we want it to be able to show up. If you notice, 135 has three different synonyms to the same thing. Once you pick one of them, you can't pick the other one. It won't let you. It says you've already got it. And you can see down here behind the screen and the message and errors, and says, hey, you've already selected that. You can't do it twice. If you know the ID, you can type on that. Water is 62. And if you know, oops, H2O, you could type on that as well. Oops, H2O, not H20. Double click or hit this button to select it from this list on the left to the list on the right. The list on the right is anything that we're going to use, any and all things we're going to use in this simulation. We can move things up, down, we can delete things, we can get them from another simulation, that sort of thing. We can even do an advanced search where we pick criteria like find me a component that has a normal boiling point, greater than 100 but less than 120. So we can find all components that would have properties of that. And it will give you a list. So you can do advanced searches that way too. But for our part, we're just going to use ethanol and water. Click OK. Now we start getting into some of the, we've got our components, so now we start getting into the thermodynamics and the calculations aspect of things. Thermodynamic Wizard attempts to look at the components that you've got selected and tries to see what kind of components there are and what data that we have for them for the systems of equations that we have, and tries to pick a best guess on what's the best thermodynamic model to use. This is only a best guess. It is still up to the engineer's knowledge and thought to pick the correct one. We can get you close, but it may not be the absolute best. And at times we may pick the wrong one. But this is, again, a best guess. Temperature min-max and pressure min-max refers to the ranges that this simulation might see. Binary interaction parameter threshold is just says half of them should be here. If we want to ignore something, let's say we have a Dowtherm that's just going to be a utility, it's not actually going to interact with the process, we could select that and ignore it. Fill out that information, it goes through and it selected, it says NRTL and latent heat for this. Okay? We give you the next screen, and that has all, I believe it's 40 different options that we have for thermodynamic settings or thermodynamic equations. It is still your job to pick the correct one that you're going to use, the one that you want to use. We can always help you out with suggestions and things like that. Comparing to data is probably the best way, but NRTL, and that's okay one to use for this one. We'll get a little bit further discussion of thermodynamics in the next segment and future segments. So we'll pick NRTL, which is non-random to liquid. And you can see that some of these items on the screen are gray and some of them are in black. Black means it pertains to this, gray means it doesn't. If we change to something like SRK, we see that things shifted. Go back to NRTL for a minute. So we're going to change, leave it on NRTL, and we pick our enthalpy model. The NRTL model uses latent heat to do its enthalpy calculations, so that we've matched that. So we'll leave that. Click OK. And it says, hey, I found some binary pairs for NRTL. Since this is an activity coefficient, it looks for the activity coefficients or binary interaction pairs, non-ideality essentially. If it didn't find any, it might just default back to an equation of state like SRK or that sort of thing. On this screen, we can even get that tab button and look at the data, where the data comes from. If we've got multiple sets of these, we can pick multiple, which one we want to choose. So now we've got our flow sheet drawn, we've got our components set, and we've got the calculation routines that we're going to use to do the calculations. The only thing left to do is start doing specifications, putting in the numbers, and actually doing the calculations. We can start by just double-clicking a stream. Oops. We'll put in some information here. We can click the flash button and do a flash calculation at this point. ChemCAD tells us that it is all vapor at these conditions. We have these two items in red and this in black. The top three items, you can only specify 2 out of 3, and you have to specify 2 out of those 3. The Gibbs phase rule says once you specify 2 out of the 3, and you've specified the composition, which we are fixing, then the other one's automatically fixed. We sum up the total, the component units for the total flow in this case, to give you these numbers. If you wanted to do some different calculations with this, you can. You don't have to specify a temperature necessarily. You can specify a vapor fraction. This gives you a saturated vapor at that temperature. That corresponds to the dew point, the point at which just a little bit cooler, we will start dropping out and condensing things. If we wanted to specify this vapor fraction of 0, and we did a flash, this corresponds to a saturated liquid, or the bubble point. There's two very special instances when you type in the vapor fraction of 0 or 1, that's always the bubble point and the dew point for a mixture. It'll always be at the saturation point. In the instance that we did, we're at 300 flash. In this case, because this is black, you know this is a calculated value. That tells you that more than likely this is going to be in the superheated range. How far superheated, we don't really know unless you did that other calculation that we just did. If you remember, it showed the saturation point was 263, so we're roughly 36, 7 degrees superheated. But the point being is if ChemCAD tells you that this is a 1 in black or a 0 in black, normally that's in the superheated or subcooled range. Okay, we click OK here. We can do, before we even get to anything more, we can do stream properties, select properties. As soon as we click the flash button on that stream, all of these values were calculated. The checkboxes just simply show what we would see, what we want to see on a report. So you can check box things on or off depending on what you'd like. So report, stream properties, select streams. You can get there that way. You can also do right click and do view properties. And we can see we've got this information. We break it down into vapor and liquid. In this case we have no liquid, so it's just vapor. Though we do break it down into the different sections. We're going to cool this down with some cooling water. We're just going to put through 1,000 pounds. We want to get this stream 1, we want to cool down to 250 degrees. So we're going to say we can, if you follow the green here, the green indicates the minimum information that you have to enter in order to satisfy the degrees of freedom to solve the equations. We can only specify one thing. We want 250 degrees. We have cooling water, but we don't necessarily know if we've got enough cooling water. But we know that cooling water can't go above a certain temperature or we've got problems. The hottest we can get our cooling water is 105 degrees. So we'll put that as our specification in. So that means this will go from 85 to 105, and we'll see how much cooling that we get on that stream. The next unit operation to set is our flash. Under the normal flash mode, it is just acts like knockout drum or knockout pot. Material comes in. At the pressure that it comes in, if there's vapor, it goes out the top. If there's liquid, it goes out the bottom. That's it. But you can change the mode to different options and do different thermodynamic calculations on this. Change the pressure and then recalculate. Or specify a particular vapor fraction, and you figure out, have ChemCAD figure out what else is needed in order to have that happen. In reality, that's probably more than one unit operation. You might need a heat exchanger and a valve to drop pressure and some things like that. ChemCAD doesn't necessarily care about that. It's just doing a thermodynamic calculation of what thermodynamically would happen or be needed in order to satisfy that. We're just going to use it in its standard form, or the default option. So we've specified everything that we need at this point. We can right-click and we can run this unit up. We can choose the Run All button, which runs everything, or we can choose Run from here as well. I like to do, especially the first time through, to make sure everything's working, just kind of run this unit up, and then you do a unit up at a time. So now we've got information here. As you can see, if we just hold our cursor over, we get the little information box pop up and says we've got the 263, which is not cool enough. But it also says our vapor mole fraction is now 0.99. We've got nothing coming out of here because we haven't done the calculation on that yet. That's the difference between doing just run this unit up and run all. So we've got a little bit coming out the top. Most of it coming out the top and a little bit going out the bottom. We want to get this down to 250, so we know we need more water. So now we're trying to solve a problem with ChemCAD. So we've got it set up. We want to solve something. It's kind of how you use ChemCAD, is to solve some sort of simulation problem. In this case, if we change this heat exchanger and we use utility option number 1, we can back calculate the flow of stream 5 to tell me how much water I need and we can then, as it says here, pay attention to the greens, enter 2 specifications. So I want 250 degrees on that stream. If the flow is fixed on both of these 2 streams and the temperatures in are fixed, you can only fix one outlet temperature. By degrees of freedom, you've fixed the other one. But because we've not fixed the flow, we can fix 2 temperatures instead. So click OK. Now in this case, let's do a run all. We can come down here. We can see we've got the 250. Our vapor mole fractions hovering closer to in the 50-50 range. So we've got roughly 500, a little over 500 pounds going out the top. Most of that, more so ethanol. And we've got a little under 500 pounds going out the bottom. Again, more of that water. So now we've set up a simulation. We've solved some problem. We've had a mixture that was a little hot. We cooled it down. We needed to cool to 250. The question was, how much water do we use? We can come in here and we can look at, do this and do view properties, standard liquids gallons. So we need 39 gallons per minute to do so. At this point, the next step would be to save it. Do File, Save As. Under normal circumstances when we're working, it's just an untitled document. Similar if you just started working on a Word. If we click the X button at that point, nothing would be saved. To save it, click File, Save As, like I said. In the My Documents folder, we install a folder called My Simulations. That is the default by where we start to do saving simulations. We will call this Essentials, topic 1. So now we see, and you can see the path up top that we have saved this here. If we do over to recent documents, now you can see that we've got some recent documents here. You can see when you do file open that we've got it here in this .cc6 extension. That is the ChemCAD extension that we use. Everything that you would need for that particular simulation, all of the files, all of the component information, physical properties, are all inside of that file. So if you need to share this with a coworker or something to that effect, all you need to do is share that file with them. Okay, so that concludes the introduction and basic flow sheeting. It went a little longer than the 45 minutes, so I apologize. I got a little long-winded, I guess. But to recap, we basically toured the interface. We looked at the parts of the screen, how we can move things around, set it up to how you want it. We built the flow sheet, which is the whole point of using simulation in general. Put it in, get some answers out. We specified it. We ran it. We saw how to solve the simple problem that we were trying to solve, and then we saved everything. We do have just a couple minutes for questions if we've got. I think I'm getting the information that we've got one question. The question is, how do we know which heat exchanger is what I need? Because if you open any equipment, they show the same parameters. So if we go back to ChemCAD, let me pop this, make it stay for a second. If we choose any of these heat exchangers, and we only put one stream in and one stream out, it will always default the dialog screens to the simple heat exchanger. Always. If we pick any of the the icons that have 2 streams in and 2 streams out, it will always show this dialog screen. Those are the only 2 different dialog screens that you have for a heat exchanger, period. Now, some people may say, well, we've got lots of these other different heat exchangers. Which one is the correct one to pick? It absolutely does not matter. They are all just pictures, just symbolic representations. So visually, when you look at it, it makes sense because that's maybe how it looks in the plant, or that's what you think of a heat exchanger looking like. So when you look at the simulation, when your eyes hit that spot, you say, oh, that's the heat exchanger. That's all that it means. So let's pick this heat exchanger number 15. I'll put it on here. I'll double click, simple heat exchanger screen. If I right click, I can swap this unit and I can pick this heat exchanger instead. It will reconnect everything. I can double click it, exact same screens. So any of the icons, they're just pictures. The underlying code and dialog screens that go with it are the important aspect to the things. So the answer, it doesn't really matter which heat exchanger you pick. The difference being is if there's 2 streams coming in and 2 streams going out versus 1 stream in and 1 stream out.